In this video, we're going to go through the rules for how we name organic compounds. I imagine you've already looked at how we name inorganic compounds, but organic compounds require their own particular set of rules. So why do we need a systematic system for naming organic compounds? Well, you can see it's quite clear. If we've got thousands and thousands of organic compounds in no system, then they all get given what we call trivial names. And in this table here, I've put the trivial names for the first 10 carboxylic acids. So methanoic acid would be formic acid, is its trivial name. That's what it used to be called before this system came in place. And you can imagine that if we had that system for all the organic compounds, it would be absolutely impossible to know the structure of a compound that someone was talking about. But by following a logical naming sequence, we can work out what pentanoic acid would look like. So let's get into the rules about how we actually name these. So the first thing we have to do is identify the longest carbon chain, and that gives us the stem of the name, so what the name will be based around. So you have to look at the structure and identify the longest carbon chain, and if that carbon chain had 4 carbons in it, then we would start with bute, which would of course come from the alkane butane. So that's where we're going to start. The next thing we have to do is identify any functional groups. And the functional groups are either put before the stem or after the stem, depending on how the other part of the name is forming. So if we've got an alkene, so we've got a double bond there, it will end in ene. So we would start in our example before of bute to mean 4 carbons, and then we put ene on the end to say that we have a double bond. Now we have an alcohol, it depends on the other part of the name. So it would normally end in ol. However, if the end of the name is already occupied by another functional group with a higher priority, more on that later, then rather than ending in ol, we start with the prefix hydroxy instead. So the compound that we have there at the moment we would call propanol. So an aldehyde, if we just have the aldehyde group there, and there's no other higher priority groups there, it will end in al. However, if we had a carboxylic acid there as well, then rather than ending in al, it would end in a different name to represent a carboxylic acid. So we'd have to start with the prefix oxo. So here are our carboxylic acids, and as I've just said, we will end in oic acid if we had a carboxylic acid. So here I've got 3 carbons then, so it's propanoic acid. And finally for this page, we're going to look at nitriles, and these will end in nitrile if we have a C triple bond N in the molecule. So carrying on, if we have a haloalkane, they always start with a prefix for the molecule. There isn't a suffix, so either chloro, bromo, or iodo, depending on which one I have. So the one that is shown there, we've got chlorine in there, and so at the moment we would call that chloropropane. So moving on, we're going to look at ketones. So a ketone ends in -one, and if we have a higher priority group, it would start with oxo like an aldehyde. Amines, we either end with amine or we would start with amino. And for amides, we end in amide, so that's nice and easy. And for acyl halides, we end in ol halide. So that one there would be propanol chloride. So that is a lot to take in, particularly as you may not have met many of these groups yet. So don't forget, you will come across each of these functional groups in far more detail as you go through the course. The main idea is you just get a bit of a feel for how you would name these when you come across them. So going back to our carbon chain then, if we have branches in it, we would name them methyl or ethyl, depending on how long they are. So if we have a look at this molecule there, You can see here I have a methyl group, and here is an ethyl group. I can identify my longest chain as being that one there. It depends on which other way I go, I can never get up to 6 carbons. And here I also have a methyl group there. And we also need to indicate where the functional group is. And we always try and use the lowest numbers possible. Now, if we have an aldehyde, a carboxylic acid, or a nitrile in there, then wherever that group is, that becomes position number 1. And if there are 2 or more of the same group, then we would use di, tri, or tetra. So let's have a look at this molecule here. You can see that I've got 6 carbons, so it's going to end, we're going to start with hex. There's no other functional groups there, so it's going to be hexane, but I've got 2 methyl groups and an ethyl group coming. So I need to put those in alphabetical order, ignoring the di, tri, or tetra. I've got 2 methyl groups on carbons number 1 on carbon number 2 and 1 on carbon number 4. So we have them there and there. And I've got an ethyl group on carbon number 3. Now ethyl becomes before methyl, so it's going to become, we've got the hexane there, and then it's going to become 3-ethyl 2,4-dimethyl hexane to give the full name of that molecule. So if we happen to have more than one functional group, then numbers are separated by commas, and the groups are listed in alphabetical order, as we just looked at there. So for this molecule here, I have got a chlorine and a bromine. B comes before C, so we're going to start the name with bromo, followed by chloro. By starting the numbering at bromine, I can use the lowest numbers, so therefore this would become 1 bromo 3 chloro butane. So for this next molecule there, on the right hand side, we have got in the chain 5 carbons. So that is 1, 2, 3, 4, 5. So we're going to start with pentan. It's an alcohol, so it's pentanol, and that OH is coming off the 4th carbon, so it's pentan-2ol. And then we've got a bromo and a methyl group coming off that 2nd carbon, and they need to go in alphabetical order. So it becomes 2 bromo, 2 methyl, pentan, 4-ol. Right, so going on to our next rule, where there are 2 functional groups, both would like to end the name, so with suffixes, the preference for the one to have the suffix goes in that order. So carboxylic acid always wins, followed by acyl halides, then amides, nitriles, aldehydes, ketones, alcohols, and amines. So now we know that, let's try naming these compounds here. So the first one, you can see that we have got a carboxylic acid group on one end, and we've got an aldehyde group over the other end. So the carboxylic acid takes precedent over the aldehyde. My carbon chain, this is a bit sneaky because we use skeletal formula here, but my carbon chain has got 1, 2, 3, 4 carbons in it. And we're going to start by putting the carbon number 1 on the carbon where the carboxylic acid is. So the stem of the name is going to be bute because of the 4 carbons, and it's going to end in oic acid, so it's butanoic acid. And then because I've got an aldehyde, I'm going to put oxo at the beginning of it, so it becomes 4-oxo-butanoic acid. Oh. Right, so we've got our first nitrile here. So let's have a look at that. So let's have a look at the carbon chain with the nitriles on. So I've got 1, 2, 3, 4, 5 carbon chain there. So it's going to become pentan nitrile to end. But I have an ethyl group coming off carbon number 2. So this becomes 2 ethyl pentan nitrile. And just because we love them so much, we've got another nitrile there. So again, let's start with that carbon number 1, 2, 3, 4. So again, now we've got a 4 carbon chain, so it's a butane nitrile. But coming off carbon number 3, I've got a bromo group, and coming off carbon number 2, I've got an ethyl group. So this now becomes 3 bromo, 2 ethyl, butane nitrile. Obviously start carbon number 1 where my aldehyde is. So it's first of all butanal. Coming off carbon number 2, I've got a chloro group, and carbon number 3, I've got my alkene. So what this rule means is we can generate the name by putting it as 2 chloro but 3 ene al. So rather than we put the ene to say I've got a carbon-carbon double bond on carbon number 3, and then the al on the end. Just makes your life a little bit easier. The other thing you've got to be careful of is you don't always need a number. So just think about this one. So let's have a look at this molecule here. This molecule is, you would normally call this 2-methyl butane. However, if it's methyl butane, it doesn't really matter where that methyl has to be on the second carbon because for it to be methyl butane. If it was on this carbon, for example, rather than that one, it would still be 2-methyl butane. That's how it's got to be. If it was on this carbon or this carbon, it would be extending the chain, and it would become pentane. So you don't need the number for that. It's just methyl butane. And finally, if we have numbers in the name, they're separated by commas, and words and numbers are separated by dashes. So for this molecule, we've got 2 methyl groups coming off. So we've got a methyl group there, a methyl group there, and a chloro group there. My carbon chain has 1, 2, 3, 4 carbons in it. So we're looking at it being butane. Alphabetically, chloro comes before methyl, so it is going to be a 1 chloro and then 2, 3 dimethyl butane. And that just gives you the complete name. And you can see that where I've got a number and a word, they have been separated by a dash, which is there, there, and there. And any two numbers are separated by commas.